the refurbishment of the Hubble Space Telescope, we'll be able to continue observing Fomalhaut using advanced camera and improve our understanding of its orbit. And later on, when JWST launches, we'll be able to start to probe the inner regions of the Fomalhaut solar system. And as you know, our own solar system has a rich diversity of planets, terrestrial planets and gas giant planets and additional dust structures. And we'll be able to start to look for those same structures in the Fomalhaut system. So we're really looking forward to future opportunities to observe this system in more detail, and we think that it's going to provide a lot of rich material and discussion for both observers and theoreticians in the coming years. And I will finish there and hand over to Sarah, who will comment. Thank you.
Good afternoon, everybody. This is a landmark discovery in exoplanets because it's the first direct image of an object that everybody would agree is a planet. This is because, as we've heard, of its low mass, its association with the dust ring, and the orbital motion of the planet in part of its orbit around the star seen for the very first time. I want to start by putting it into context with other previous claims of directly imaged planets. We've heard of several different objects in the past that have been called directly imaged planets. And the problem with these past claims was that not everybody agreed they were planets. In fact, most people would say they weren't planets for a variety of reasons. One case, the host star was a brown dwarf, a failed star. Other cases, the masses seemed too large. Planetary scientists are comfortable calling something a planet if the mass is low enough so that the planet doesn't generate a lot of its own energy inside, almost no energy. And we have a sort of an arbitrary cutoff at 13 Jupiter masses. I can come back and talk about this later. But for now, I just want you to know that the previous several claims are in a very gray area. A few people held out and thought they might be planets. Most people didn't, largely because of the masses. The new planet that we're talking about today, Fomalhaut B, is in the white area. It's in a sort of safe area that we all can call a planet. And this is why it's such a significant discovery. In that way, it legitimizes the whole field of direct imaging and marks the start and the maturity of this new technique that we can now look forward to a lot more results. I want to just get back to the mass issue for a second. As we heard in detail, the planet does not have an actual measured mass. It's like looking at a light at the end of a tunnel, a bright light. You don't know how heavy the object that's generating that light is. Maybe it's a handheld flashlight. Maybe it's like a very, very heavy searchlight. You could probably infer it just based on thinking about how bright it is or how far away it is, but you really don't have evidence. This planet, we have good evidence that it's of quite a low mass. And one more thing about the system is, as we heard, the planet has an 800-year orbit, and it's around a star with this beautiful dust ring. And in that way, it's very different from our own solar system. And it's great. It stretches our imagination of what a planet can be. And it gives us hopes about all the other exciting discoveries we'll find. Now, finally, I just want to share with you the saying that we really like in exoplanets. All roads lead to terrestrial planets. And, of course, Rome wasn't built in a day. And many of us here have worked for many years on an idea that would be called terrestrial planet finder. And our ultimate goal in exoplanets, for many of us, is to do this kind of direct imaging and to come back here sometime, hopefully in the not-too-distant future, and talk about a directly imaged system that has an Earth in it, where we can actually see that Earth directly. So many of us are looking forward to that day and congratulate our discoverers on one of the first steps towards that. And now I'll turn it over to my colleague, Mark Kushner.
Thanks, Sarah. So my name's Mark Kushner, and I work on predictions for what planetary systems like Fomalhaut would look like. So both Sarah and I have been working on the theory of planetary systems. Maybe Sarah's concentrated more on what the planets look like, and I've been focusing on what the dust disks look like. So first, let me say again what a remarkable discovery this is. So Thomas Friedman says that the world is flat, now staring across the ocean of space and looking at our nearest neighbors in space. I'm beginning to think that the universe is flat as well. Second, coming from the perspective of someone who studies dust disks, this is very exciting because we've known Fomalhaut for a long time, and we've known for a long time about the dust in the system and the the ring of dust that's sculpted as though they were a planet sculpting it. And now we have the planet itself. The dust in this system is sort of like planet crumbs. And Mark and Paul followed the trail of crumbs, and lo and behold, they found the planet. And they didn't mention that there are a lot more dust disks out there that we're going to want to study hard and follow those trails of crumbs as well. We see, of course, in the solar system examples of planets sculpting dust. Mark mentioned how Neptune interacts with the Kuiper belt. Also, we see dust in the inner solar system sculpted by the Earth. So the Earth creates a ring of dust around the sun. The dust comes from asteroids and comets and gets sculpted by the Earth into this ring. But this is the first example we have. Fomalhaut is the first example we have of a extrasolar planet where we see the planet and we see the ring that's being sculpted, and we can put together the two sides of the story. And I think Fomalhaut's really going to be a Rosetta Stone that's going to allow us to decode future images of disks like Fomalhaut and find future planets using this technique. I also want to remark about the subtle ways that the Fomalhaut system is different from the solar system. So the Fomalhaut B planet is a very massive planet compared to planets in the solar system. It's still very distinctly, as Sarah pointed out, a planet. But it's a massive planet located far from its star. And to a planet formation theorist who's used to making predictions based on the solar system, it's almost like they went fishing in a fishbowl and they pulled out a whale. So it's a very massive planet located far from the star where massive planets maybe shouldn't be. So we're starting to think perhaps this planet formed via a mechanism that doesn't operate very strongly in the solar system. Maybe it either migrated outward or perhaps it formed maybe directly from the collapse of a disk, more in the manner that a star would form. This artwork shows something else interesting about how the Fomalhaut B planet is special. The Fomalhaut B planet is somewhat brighter than you would expect if you were just seeing light from the planet's surface. And that suggests that perhaps the planet is orbited by a ring of material which is also scattering light towards the viewer. And this makes sense to me, given that we have a beautiful ring around one of the planets in our solar system, namely Saturn. So thank you, and now back to Ed.
Okay, you guys said most of it. Let me just say a few things. There are probably some skeptics out there over the years, over the last 2 decades, who didn't quite believe that we discovered planets when the ground-based astronomers found stars moving back and forth, which was an indication there was a planet there, or stars being pulled, and we saw the velocity change. They were from Missouri. They wanted to be shown. Well, today's the day we're showing you the picture. Second thing I wanted to sum up is there's always a question, well, how far away is this thing? We forgot to mention it's about 27 light years. In more human terms, I did the calculation, that's about 160 trillion miles. These days, we all seem to have more understanding of what trillions are, so I thought I'd point that out. So that's it.
Thank you all. Okay, now we're going to open up for questions. Before we go to the phone lines, do we have any questions? Can you wait for the mic and give your name and affiliation, please?
Schwarzschild Physics Today, Sarah.